Hello, everybody. Welcome back to the Tokyo FinTech podcast. Today, I'm here with Kristof from the ThreeFold Foundation. Hello, Kristof.
Hello, everyone. Thank you for inviting me on your podcast.
I work a little bit like the Google algorithm. I talk to many people, and when many people point to the same project, that's like something we should bring onto the show. And a number of people who pointed to ThreeFold and the ThreeFold Foundation as something that is super interesting. So here we are. Thanks for taking the time.
Thank you.
But before we even get into ThreeFold, you have a super interesting career as a founder, as a technologist. You've been in the data center space for a long time. Maybe you share some of that with our listeners, please.
Sure. I'm from origin a nerd engineer. So I started coding when I was 9. I understood computers, I guess, better than people at that time. Maybe I still do, who knows. I was lucky when I came out of university. It was all about the internet was just starting. And it really got to me. It was beautiful, everyone getting online and all connecting to each other. And I was lucky to be able to work for the first American ISP, which was called PSINet. Well, it was a global ISP, actually. And for them, I could build things in Europe and we built data centers. And then in 2000, there was still at the top of the hype in 2000 was like, oh, why don't you start your own companies? And that's when I started. That was a little bit the wrong time, I would say, because it was already at the top. But yet still, we were rather successful and we had startups around internet and storage and automation. We did a number of startups and we sold 6 of them. And it was always around technology because that's really where my passion is. And about 10 years ago, it was like, okay, what do we do? A little bit my midlife crisis. What do we do? Do we create yet another company or do we do something with everything we've learned for the planet? And that's how we came to this ThreeFold idea. Yeah, that's where we are and become something very different than what I'm used to. But we pulled everything together in sort of one idea, where basically we work first for the planet and then for everything else around that.
And so obviously the internet wasn't created for the scale that it has reached now. And so some of the design decisions that have been made under very different assumptions. So you had the benefit of some learnings along the way as to the deficiencies of the current internet, and you're building the next generation. So how is the next generation going to be different?
Well, first I probably need to explain when we talk about the new internet, we're really talking about the capacity, because today most people think, oh, it's the cables, but the cable problem, the connections problem is actually rather well solved. And that's how the internet started. It was a connectivity mechanism. How could people connect multiple networks? That's one of the reasons that we have issues today, which is it was only conceived to connect things. They didn't think about security, authentication, how to store. All of these things were basically an afterthought because no one knew what was going to happen or what did happen afterwards. That's why we are in a little bit of a disconnect. So today there are lots of cables, and today you have even beautiful peer-to-peer networks. Like in Spain, as an example, where I am right now, there are 60,000 nodes having a peer-to-peer internet where they literally all connect themselves over wireless, over air, and they build out their own internet. So the connectivity part is kind of, not in emerging countries, but is kind of getting there. The big issue today is how these massive big data centers are built. So maybe for the listeners who don't know, but today everything we do on our apps gets hosted in these big, huge data centers, like big buildings with millions of servers all put together. And we have all our stuff there. And there are less than 20 companies in the world have more than 80% of that capacity, of your storage capacity, your applications, your data, actually your digital life. And that's where we see the disconnect. So it's very power hungry, very centralized. Our data is being abused. And we see a new internet where we don't want to do it like that. So we're inviting people to extend the network, to do it themselves. So everyone can buy a piece of hardware. They can just connect the box to the existing cables, to the existing internet. And as such, you get a new network of capacity, which can complement what's out there today. But this is a new internet, which is owned by all of us. Everyone adding a box to it extends the network and owns a part of this new internet. But an internet where everyone is free, where everyone's data is close to themselves, where the data cannot be abused, where you use a lot less energy. So a more conscious internet, I would say.
And these boxes that we then install, they act both as a storage and as a processing layer in essence?
Yes. So these boxes, it's to make it more easy. I sometimes talk about solar panels. Just like today, you can buy a solar panel and it will produce electricity, and you produce electricity for the people around you, right? Because you can give it back to the grid. It's a similar way how it works. So you buy a computer, you download the software, you start it, You don't have to be an IT expert because our technology is self-healing. So you don't have to know anything about that. And you just click it into, or you plug it into your internet connection. And that way you extend the network. And yes, it's compute, storage, and networking capability. So it can allow other people then to run certain things on that box. But it's done in such a way it can never interfere with your home, of course, or it can never interfere with who you are. So it's super safe. We had to do a lot around that. And individual people can do it, but schools, governments, data centers, commercial companies, so everyone can basically extend the network that way and make it bigger. That's sort of the idea.
How do you make it safe and cheap at the same time?
The easiest way probably to explain is that when I started coding, I had a Commodore 64. Which was this little machine. And it had 64 kilobyte of memory. That doesn't say much, but that's really like today, nothing. 64 kilobyte is like literally nothing. But yet still that machine was very capable. It could do so much, right? If now I look at my laptop, it literally has 10,000 times more capacity, 10,000 times more. But did it become 10,000 times more capable? Of course not. So you see that somewhere in that evolution of going from a capable computer to what we have today, also a lot of efficiency got lost. And this is because IT is a complicated business and there are many layers on top of each other. So it's like very complicated. And every time something happens, there is a new layer which does something else. And that way you get this complicated system, and that complicated system became big. Like in your computer today, you have maybe 4 gigabyte of memory or 8, and it's still not enough. But it doesn't make sense. That's really weird, right? So why is that? And that's because of this complication which is being added. So what we did is basically working on that. Which is like, but what if we really go back to the basics, forget all these layers and just go back to, we have memory, we have a CPU, we have a disk, and we have recreated an operating system, which is basically the low level thing which runs on top of this computer. And it allows us to be much more efficient. Because of going so much more low level to the hardware, it became much lighter because there are less layers to deal with. There's less overhead. Because of it, it uses a lot less energy. We also have some special algorithms which allow us to use a lot less energy. And because of that, it becomes less expensive as well. Because if with the same hardware, we can do 3 times more or 10 times more, then obviously the cost of producing that storage of compute will become a lot less expensive. And maybe the last thing which people don't know, which is kind of funny one, most people probably heard about Moore's law, the fact that the CPUs become faster and faster and faster. But at one point in time, it couldn't do that anymore. And then what did they do? They said, okay, you know what? One computer doesn't do it anymore. We're going to put it in many compute cores, but many like separate computers, if you want, separate CPUs all next to each other. And that's today the situation. But what is the big downside of it? And people don't realize is that your computer has maybe 16 of these mini CPUs. And it needs to give time to everything which runs on it. But every time it needs to give some time to an application, it needs to allow you to come into the CPU and you are going back out. And I hope I'm not getting too technical, but that is, they call this context switching. And this is what we as people do. Imagine you are behind your computer and someone comes to you every 5 minutes, asks you to do something else. Your output would be nowhere because it would be not efficient enough. And this is exactly what happens today on your computer, on the internet, even on your phone. So your phone and your computer is literally sometimes 90% of the time doing not much, just like trying to keep everything running and getting this compute time. And that's basically what we resolved. So we try to be just much more efficient in how to use hardware.
And I think we're about the same age. So my time as well was a big question. Are you going to buy a Commodore 64 or a Zenith 80? And the difference was the 16 kilobyte of memory, right? The Z80 versus the C6. Yeah. Big decision a long time ago.
Yeah, but it was incredible what you could do with these machines. You could literally read the memory. Right? It was only that big. And I did. It was 64 kilobytes. So this is readable. Yet still, it all worked. And then today, if you look, like my tab page on my Chrome is sometimes half a gigabyte. Yes. How did that happen? That's so we have to go back to, it's almost like the world today. Also in this world, it became so overloaded. So much stuff. It's like, do we need all of that? Why can't we go declutter? Let's go back to something much more simple. And if we go to something much more simple, we are more happy. It's more efficient. We don't have to deal with all of this. And in a way, this cleanup thing is the same thing with computers. We just need to go back to something much more simple.
What does it mean for people developing on that architecture? Do they need to move to lower level programming languages again, or how?
No, because that wouldn't work. Because people learn other things on school and they're now used to certain convenience, because it is a fact, it became more convenient. So what we had to do, and that was a lot of work, so we had to create this new operating system, which gives us these efficiency gains. But then we had to make it compatible with the existing IT environment. So today in the IT world, you have these things like Docker, Kubernetes, whatever, these different technologies which are very popular. And we basically allow them to run directly onto our system. So that's half of the answer. So, and we have like importers if you want, and it's easy for people to move or copy what they have or recreate it, but by using the same tools they're already used to. And that makes it easier. That's one thing. The other thing is one of the workloads on top of our new internet, we call it the crystal twin. The technical name is ThreeFold. If this crystal twin is your digital avatar, it's your twin, it's you. But instead of having 100 applications like today, because it's not my quote, it comes from Elon Musk, but he said we are a cyborg. And what does he mean with that? He says, because of the phone, you use it constantly, or your computer, you become a cyborg because you can't live without it anymore. But now comes the problem, you don't own the data and the applications on there. And that's really strange, right? So we allow ourselves to be a cyborg, but we don't own the data or we don't own the applications. That is not okay. And this digital twin I was talking about, or the crystal twin, is basically about giving you back all your applications and all your data. So it's linked to you. And there, if you, as a developer, you want to use that system, you would have to indeed learn how to work with that. It's high level. Any JavaScript or web tool can be used to work against it, but you would have to understand the features or the capabilities of this crystal twin, this digital avatar.
Is that what we would refer to as a self-sovereign identity then?
It goes much further. Self-sovereign identity, in most of the case today, and it's a great question, they put it on a blockchain. So what are the options today? If you say, look, I'm a software developer or I have an application and I want to bring it out there, I want to give this to users. So you can go to central data centers. That's what most people would do in Amazon or Google, Microsoft, and so on, right? But there we have the issues we talked about. It's super centralized. You don't own your data. It's using too much energy, and it's also expensive, actually. And then you have this new wave of blockchain, which opened up a lot of things where people are like, oh, wow, this blockchain allows us to collaborate and work together with millions of people and find consensus. Now, blockchain is really a great new thing which happened. But one of the things which people maybe don't know is that blockchain is great for certain use cases like money, digital currencies, or getting consensus or a smart contract. But that's where today it pretty much stops. And it's pretty bad at doing more things. So back to your question, if you have this identity solutions today, they like to put it on blockchain. But there are issues with that because people want to have their privacy, but a blockchain is not private. A blockchain is shared amongst a lot of people. So we believe that this is not necessarily the most optimal solution. Having something where you have your own digital twin and it's yours and only yours, right? And it lives there autonomous, maybe even in your home. It doesn't have to be, but it can. But it's really only yours and it lives there and it has your data, your identity, your applications, it's your full digital life. Everything changes. And yes, identity is a small part of it because of course our identity, but we need to own our identity, not some bank or not some blockchain. It needs to be we, so we can decide, okay, to who do we give out our identity information or news or anything else. So yes, it's a part of it, but only a smaller part.
So can I just dream up a use case? So if I have my digital twin, and because I'm running with a watch that takes my heartbeat and all my biometrics data, I can then send my digital twin to my digital doctor who's got all the data to look at. It does my annual health checkup in the fully digital world, almost the same way as if I was physically there.
Yes, exactly. Today, medical is a very good use case because right now with the COVID thing, as an example, it's one of the things we're working on, where people are like, okay, but I'm tested and I want to show to other people that I was negative or I have the test results, but how do you deal with that? Do you want a doctor to have that? Maybe not. Do you want to put it all in a central database? Maybe that's not the best solution either. Do you want to put it on some shared blockchain? That sounds too cumbersome too. If you have your own digital twin, your avatar, that's you. I mean, you are the only person having access to that. And you go to your doctor physically or not, and it's like, here. Now you can leave the information and the results, and these crystal twins can talk to each other. And now my digital avatar basically gets the information, keeps it for me. And that way we know it can never be taken advantage of. If someone wants to use it, they will need our permission, which is different. It goes for, of course, medical records, but it can go for anything. It can go for information, news, a blog, anything actually.
How do we secure the data then? It's great if it's all in one place and I own it. How can we make sure it can't be hacked and then completely exposed because everything is in one place?
Well, that's already the case today anyhow. Today you have, because you exist 100 times, you can 100 times be hacked. So that's already and because you're in these shared infrastructures, it's much easier for hackers to do something. Because how do you avoid hackers? It's becoming a bigger problem all the time, is by what they call minimizing the hacking surface. So basically, the less surface there is for a hacker to do something with, the less chance the hacker will have to succeed, right? And that's exactly what we do. So by basically giving you only one place you need to look at, and you are the only person being able to go to your ThreeBot, and you also need your phone, the hacking surface becomes very small. Because if you have 1 million people on there, you actually have 1 million individual secured items. So even if in the very unlikely event, one person would be hacked, it stays to one person. In the case of now, if Facebook gets hacked, boom, 1 billion people are exposed. So the hacking surface, and of course of a Facebook, is massive compared to just you as part of 1 million. And it's only one thing to secure as well. And because it's only one thing, it's much easier to guarantee that the hacker cannot get in between. And then there are lots of technical things, which I probably don't want to bore you with, but some very small things. On the internet, there's a constant thing called key exchange. So if you go to a website, you exchange a key to be able to go onto that website. And that's where the hackers, they call it the man of the middle attack. So they go in the middle and they try to steal your session. We don't have that problem because all the ThreeBots talk to each other, or these digital avatars, they're all registered in a sort of phone book, and there is no key exchange. So that's again one of the little things. So there are lots of individual things which make it super difficult for a hacker to get into. Also your data, because you're talking hacking. The other thing is you never want to lose your data. Your data is distributed over multiple locations, but you choose that. Your digital twin chooses that. And it's spread out in such a way that standard, you would have to be on 16 locations at the same time before you can physically reconstruct your original data. So that makes it very safe. So even if the hacker would have the encryption key and would know how it works and would know what all the data is, they physically would have to be in 16 locations at that time, which is kind of hard. So there's also an algorithmic part of our solution, which makes it super hard for a hacker to get to the data.
So if you compare that with IPFS, for example, which some of the listeners might be familiar with, where do you would draw out the differences?
Look, I admire IPFS because they were the first guys, I would say, building out a planetary file system, right? Which is really crazy. Yeah, they got far, but it's a shared system. It's like blockchain. It's not really blockchain, but it's similar architecture, which means that you're spreading out the data on a planetary scale, a little bit like others sharing peer-to-peer technologies. And as a consequence, it makes it slow because your data is everywhere and you have limited control over where the data is. And if you want to retrieve something, it needs to come from many, many locations. And that makes it inherently slow because it's a shared system. And I do not believe that the future is for a shared system. I believe the future is that you are the center of your digital universe. And if you are the center, it also, many things become much more simple. One little side effect, every digital twin is registered in this phone book, just like the old days, because again, probably like you said, we have the same age. You have this big phone book home. If you want to call someone, you go to the phone book and there you know the information you call. We do a similar thing. So if my crystal twin, my digital avatar wants to reach another digital avatar, it will look up in this phone book and say, that's you, you are there, and the public keys are there. So it can basically, without a key exchange, talk to the other one directly because it will find directly where you are. And what does that mean? It means that with only 2 numbers, you can address everything in the world. The number of the ThreeBot and the number of the information in your ThreeBot, which is a digital twin. Which is amazing effective because now I don't have to look everywhere on the internet to find the information back like in IPFS, but it's literally much more controlled. It's like, okay, it's in your digital twin. I ask my digital twin. So it's like 1, 2, information comes back. And that can be a video. That can be a big thing. If you ask a video from IPFS, there are many subparts and they all need to be constructed independently. And that makes it so heavy. So it's a very different architecture, which is more like nature, where cells exist, can communicate to each other. They are all independent. It's a little bit more like that. And that makes it so much more efficient.
And also, if you put it into the context of the current pandemic, there are all these contract tracing applications coming up that infringe on our civil liberty, and we might be willing to do that for a few months because of the crisis, but history shows us that these things never go away again. We're being surveyed anyway, and it's just getting worse. That could be a real catalyst for adoption of the threefold architecture.
Yeah, it can be used for many things. But we have more than 20 partners now coming on top of our network who want to use those things. But at the end, this is something we do for the planet. And we even made a sort of movement around it, which we call Planet First, which is like, look, let's do something for the planet first. It needs it. And as a consequence, it will have benefits for our investors and ourselves and so on. But if we put this planet first, what are we? We're not building a new Google. We're not building a new big company, because then eventually maybe we know better than them. Because I probably also started with all best intentions and lots of dreams, and why not, right? That's why I think by design, it needs to be much more peer-to-peer, decentralized, so everyone can add a piece to it. And then that way you get a new internet, which is really made by millions of people, not by a few. And then as such, on top of this infrastructure, you can host anything and keep your freedom and take it back. And you are the only person having your data, so it's by design more secure. Right? You don't need special mechanisms. You don't need legislation even, because it's you. You don't need legislation protecting you because it's already you. It's very different.
We're sold now and we want to go off tomorrow and get a box and hook it in. What do we actually have to do?
We are now the second generation, and it launched this month, the second generation. And now, things are live. The token exists for a couple of years. So there are a couple of things happening. One is that we're going to launch next week, actually, on 2 public exchanges. Basically, our token represents capacity on this network. So we're hoping that people want to buy these tokens, so they buy into the future capacity of the network. And that way, we also get some funding to finish what we are working on. Now, the second thing is that there are a lot of farmers already. We call people extending the network a farmer. And yes, of course, we need more farmers. So there will be also, starting next week, be a form where people can just go to fill in what they're looking for. And then, because it's decentralized, then we can point them to the right party close to them who can help them, if they want to, of buying a box and maybe get certification, because we also have certification programs. And that we extend the network. Now, already today, anyone can just buy a box and do it completely themselves. That's how a lot of people actually did it. They just bought a box, they went to our open source website, they downloaded this image, and then they put it on there and they booted it up and they went through the manual. But for some people, that's too complicated. So they rather go to a farming cooperative, we call it, which is like, just like in the real farming world, right? It's like, okay, I want to farm capacity, but I'm not going to do it all alone. So I go to a place where I can find some help, and they will tell me which hardware is the best suited, which will give me better return, as an example, with some tips and tricks how to connect it. But the easiest way to start will be just go to our website and basically let us know that you're interested. And then in June, we will help the ideas to get 1,000 more locations online. We are now in 21 countries. We have 18,000 CPU cores today and 90 million gigabyte, but we want to go to many more locations. And that will be the push. Wouldn't it be amazing that this thing is like in all countries and in all major cities, and you can get your internet everywhere? So that's now what we need to achieve.
I go back to where we started with the context switching on the multiple cores. So if I go and buy a quad-core computer now off the shelf and then run your software, am I still being more efficient?
Yeah, great question, of course. And thanks for asking, because I'm sure other people got confused too. Yeah, these multi-cores, that's the issue, but we try to resolve that, which means that the way how we let the CPU schedule the workloads, it's more that we do it, okay, in a fancy term, they call this preemptive multitasking. But basically, we make sure that for the storage and certain other of the workloads, there are a lot of less context switches happening by the way of how the software works. So you get benefits from there, and also benefits from the way how the storage works and how we spread it out. And then the rest is basically just being efficient in how we use the hardware for providing you with the compute capacity, because compute at the end is a compute, it's a CPU. Of course, if your application is inefficient by itself, there is nothing we can do, because then the application is just application, right? But everything around we can really help. And our biggest benefit really comes from the storage parts. For standard storage, we are about 10 times more efficient. If you do this for blockchain, it can be up to 100 times. If you do this for the crystal twin, it can be up to 1,000 times more efficient. But this mainly comes from the storage parts and some other things.
Obviously, if we want to farm, then I need electricity. So are we getting into similar concentration, possibly like for Bitcoin mining? Because the market would drive you to the cheaper electricity source, which would be ice.
No, in our case, electricity, because we are efficient, is only a couple of percent of the total cost. Let's say 10, maximum 20%, maximum, depending where you live. Smaller boxers, even less. So it wouldn't help that much. Right? Even if you have your electricity half price, okay, you would win 5% or maybe even less. But there are other things as important, which is, or more important, which is like the connectivity, right? How much bandwidth we have. And of course, if there are small boxes, it doesn't really matter because then it goes in homes from people or whatever. And then even today, like in Spain, and they have this peer-to-peer internet. We are not doing that yet, but we want to do that, integrate with them, is that, yeah, they are on 60,000 locations. So now imagine that on like 10% of those locations, you put a small box, right? And then your network and everything is done, and energy becomes a minor part of that total because of the way how it's distributed. That's a little bit an issue we're having today. Today, we have a lot of capacity, but it's too centralized. Well, not centralized to us, right? So that's not the issue. It's more peer-to-peer and decentralized than anything out there. But some of the farmers are too big. So this is now what needs to grow. So we get many, many more farmers in. So that way it gets more spread out and it becomes more decentralized.
So we have a few gaps to fill in Asia. So hopefully we can help people understand what it is and get excited about it and participate.
I hope so too. It's good for everyone if that happens.
So with your existing partners, what type of applications are being built?
Three main things. One is blockchain workloads. So there are quite some blockchain friends who want to use our network to use the special capabilities. Mainly the fact that it's more decentralized and more peer-to-peer. That's one. Then secondly, we have partners which more work at the application layer, like social network kind of thing, or there's some beautiful e-commerce or really nice applications, and they will run more on top of this digital avatar. That takes a little bit more time because there we need to integrate, put them on there and so on. And then the third is people just putting their cloud workloads on it. So they typically would use like an Amazon or a Microsoft or so, Azure, and they can also do it on our network. So anything which runs on Linux can run in our system. And that's basically the third thing kind of sort of happening. And then we're working with some private partnerships. We have some really big ones like HPE and some other companies, Solidaridad and some 5G compatible telco solution. And we work with them to integrate so that we can. One of the things we can do is really cool. 5G, as you know, is not very healthy. And together with a partner, we can deliver 5G, which is not frying our brain, which is still using the 4G frequencies, which is also not the most healthy thing in the world, but at least it's less damaging than 5G. And we combine our product, our service, so basically the capacity with the network. So you get this capability of building out new networking features and internet capacity all integrated with each other, fully peer-to-peer. So that's like one of the things we're also working on.
Coming back to the tokens, all the tokens are owned by the foundation?
No, they are all basically the result of farming. Of course, 4 years ago, we already started farming. And that was more, at that time, the blockchain was not even live. So that was literally like the boxes and the machines were there and we were keeping track of what we were doing. And then the blockchain launched about 2 years ago. But we have proof, because we documented all of that eventually there is always capacity behind the token. And then, as such as the foundation, because we have a non-for-profit foundation, we got tokens from farmers. We did our own farming and we have also farmers who contributed to us. And that gives us a number of tokens we can sell. And part of those tokens we are selling onto the public exchange to basically keep on funding some of the projects we're working on. Like we're working on an office thing on top of it and other things as well, like mail and chat and whatever. So they can live on top of this network. But for that, we need more funding, and that's why we're doing it.
What are the milestones in the roadmap going into 21, 22?
Well, this year is mainly expansion of the grid, getting many more farmers on board, getting people to use the token for buying and selling capacity, but also services on top of the network. And getting known, because still today we were the best kept secret, which is maybe not good. So it's only now that we start talking and start going out. So that's mainly this year, which is getting more momentum, showing people more what they can do with the capacity. We still hope to have some communities this year, which would bring us to maybe already 1 million people or so on top of the grid. But for that, this needs to happen with communities which are not ours. And we basically help people to get their community on our system. Next year, it will be much more about, of course, just growth, where we keep on building out. Now, our aim is that within 2 years, we want to have enable at least 20 million people, but hopefully more, of course, all with 80% of their digital life, so that you can have all your apps and back to you. And so we're not like this one big milestone kind of company. We're really more like every month we just want to achieve the next thing. Partners, some more farmers, a new feature of the grid, maybe a new application, and just month by month by month by month. But let's say within 24 months, what they call the big hairy goal is at least 20 million people, which can use 80% of the digital life requirements on top of what we call experiences on top of our grid.
That's a pretty aggressive goal. How many engineers are in the overall ecosystem working on this?
In the ThreeFold Tech, which is our technology company, and then the foundation, there we have about 50. Yeah. About 50, I think 50 people working on it, and then some contributors, but it's mainly internal. And then now we will also start having a separate team for the Crystal Twin specifically, and that will be another 10 plus people. That's where we are. So it's still a reasonably small team to see how far we got. We invite everyone to help us. That's one also why we're selling these tokens, and we get more bounties, so we can go back to the open source community, get more people enthusiastic to build things on top. Because it's all open source. The idea is that we all together also build the use cases on top of this.
We'll help you as much as we can. You're popularizing it in Asia. Excellent, super conversation. Any final comments, Kristof?
Thank you for bringing me here and for giving me the opportunity. And I hope that the listeners got inspired and that they want to contribute to this peer-to-peer decentralized internet network, because basically they would become a part of it, right? It would also be their network. And this is something I believe the world needs today, the ability to freely communicate and keep our own data. Yeah, let's all together make it happen. We need it.
Let's go. Super. Fantastic. Thank you very much.
Thank you.